Hello, welcome to GTech Techno Solution Private Limited. Today we are going to discuss about the urine formation and we are going to see the preview of it. So these are the topics that we are going to cover in this session. We are going to study about the composition and properties of urine, followed by the urine volume. And we'll be studying about the diabetes, diuretics, and renal function tests. We'll be studying about the urine storage and elimination, urinary bladder and urethra of a female, and a male bladder and urethra. We'll be discussing about the voiding urine, which is micturition. So let us see the urine formation in preview. The first step in urine formation is the glomerular filtration. It creates a plasma-like filtrate of the blood. So that is done in your glomerulus. And next step is the tubular reabsorption. In tubular reabsorption, the useful solutes from the filtrate are returned to the blood. So this happens over here, as you can see. And next we have the tubular secretion, which removes the additional waste from the blood and adds them to the filtrate. So you can see over here that the wastes are added from the blood to the filtrate, that is your tubular secretion. And next we have the water conservation, in which from the filtrate the excess amount of water is returned back to the blood and the concentration of the waste in your urine is increased. So this is the urine formation. Next we are going to see about the composition and properties of urine. First let us study about the appearance. Most of the urine is colorless and it is deep amber. If it is yellow, it is due to urochrome. And from the breakdown of hemoglobin, RBCs. Next we have to study about the order. Order, as it stands, bacteria degrade urea to ammonia. So this causes the order of the urine. The specific gravity density of urine ranges from 1.000 to 1.035. Next we have the osmolarity, and it ranges from 50 mOSM per liter to 1200 mOSM per liter in a dehydrated person. Next, the pH range of urine ranges between 4.5 to 8.2, and for a normal person it is 6.0. So that is the pH of human urine. Next we are going to study about the urine volume. The normal volume ranges between 1 to 2 liters per day. If a person has polyuria, then it is greater than 2 liters per day. If he has oliguria, then the volume of the urine is about less than 500 ml per day. If he suffers from anuria, then it ranges between 0 to 100 ml. At this stage, the body will be fixed with toxins. Next, we are going to study about diabetes. Diabetes is nothing but the chronic polyuria of metabolic origin. So in polyuria, the amount of urine secreted will be greater than 2 liters per day. If the condition is with hyperglycemia and glycosuria, then the condition is known as diabetes mellitus stage 1 and 2. In this condition, your insulin will be in hyposecretion and there will be insensitivity. For females, gestational diabetes occurs in 1 to 3% of pregnancies, whereas the pituitary diabetes occurs due to the hypersecretion of GH. In the cases of adrenal diabetes, hypersecretion of cortisol leads to the diabetes. If your diabetes is subjected with glycosuria but not hyperglycemia, then that case leads to renal diabetes, which occurs due to the hereditary deficiency of glucose transporters. So, there are no efficient glucose transporters. That leads to your renal diabetes. If the condition is no hyperglycemia or glycosuria, then the diabetes insipidus will be the condition, and that occurs due to ADH hyposecretion. Hyposecretion in the sense ADH is secreted below the normal level. So these are the different types of diabetes and the causes that can be determined with the condition of hyperglycemia and glycosuria. Next, we are going to discuss about diuretics. The effects of diuretics is there will be increased urine output and the blood volume will become low. This may lead to hypertension and congestive heart failure. Diuresis occurs because of increased GFR, that is glomerular filtration rate. Your filtration rate is increased. That causes increased urine output and decrease in the blood volume. Since your filtration rate is higher, the filtrate will be higher, and which in turn will lead to less tubular reabsorption. Next, we are going to discuss about the renal function tests. To test whether your renal vein and renal arteries are working properly, we have the following tests that can be done. The first test is renal clearance. In renal clearance, the volume of the blood plasma, it is cleared of waste in 1 minute. To determine the renal clearance, which is indicated as C over here, is done by assessing the blood and the urine samples using the following equation. C is equal to U multiplied by V divided by P, where U is nothing but the waste concentration in your urine and V is the rate of urine output. Your P stands for waste concentration in plasma. So by determining the values of U, V and P from a urine, one can calculate the renal clearance value. And your renal clearance is the volume of the blood plasma that is cleared of waste in 1 minute. So this is the first test to determine the renal function. And next, to determine the GFR, which is your glomerular filtration rate, we have to find whether the insulin is neither reabsorbed or secreted so far for the solute of glomerular filtration rate. To determine the renal clearance of GFR, we have the formula as U multiplied by V divided by P. So this is how one can test the renal functioning. Next, we are going to see about the urine storage and elimination. If you see, first we are going to see about the ureters. From the renal pelvis, your urine passes the dorsal to the bladder and it enters it from below, about 25 centimeters long. There are 3 layers in your ureters: adventitia, muscularis and mucosa. So these are the 3 layers you can find in your ureters. Your adventitia is CT. Your muscularis has 2 layers of smooth muscle. Your urine enters and it stretches and contracts in the peristaltic wave in your muscularis. Whereas in your mucosa, the transitional epithelium is the region that controls the urine. Your lumen is very narrow and it is easily obstructed. So this is how the urine passes through the ureters of a human urinary system. Next, we are going to see about the urinary bladder and urethra of a female. So for a female, you can see that the ureter from the kidneys joins in the urinary bladder over here. And the outer lining of the urinary bladder is parietal peritoneum, inside which one can find the detrusor muscle. Your ureters come all the way from the kidney and have their openings over here as urethral openings, which fills the urinary bladder. This region in a triangle is known as the trigone, and it helps in emptying the urinary bladder. To control the elimination of urine, we have the internal urethral sphincter. The sphincter muscles control the elimination of urine from the urinary bladder. And the next set of sphincter muscle is located over here as external urethral sphincter muscle. And this is the external urethral orifice. So this is the urinary bladder and urethra of a female human. Next we are going to see the male bladder and urethra. For a male, the bladder is about 18 cm long, and it has the internal and external urethral sphincter muscles over here, as you can see. There are three regions for the elimination of urine: the prostatic urethra, which can be found over here, your prostatic urethra during orgasm receives semen. And next, we can find the membranous urethra over here. It passes through the pelvic cavity, which is your hip bone. And then we can find the penile urethra. So this is the male bladder and urethra. If you see, in a female urethra, it is about 3 to 4 cm long. And you can find the external urethral orifice over here. And it is between the vaginal orifice and clitoris. And next we can find over here the internal urethral sphincter muscle, which helps in controlling the outflow of the urine. The detrusor muscle is thickened, and we can find the smooth and involuntary control of the muscle over here. It is a smooth muscle and it has involuntary control. Whereas your external urethral sphincter muscle can be found over here, and it is a skeletal muscle and it has the voluntary control. So this is about your female urethra. Next we are going to see about voiding urine, which is micturition. Micturition reflex is nothing but the action of informing that the bladder is full and it has to empty itself. If a person has 200 ml of urine in the bladder. Then the stretch receptors will be sending the signal to the spinal cord S2 and S3. The parasympathetic reflex arc from the spinal cord will be stimulating the contraction of detrusor muscle. The relaxation of the internal ureter sphincter occurs at this point of time. So, the micturition reflex predominates in infants. As we know, for infants, the reflex action will be less voluntary. Next, we are going to study about the infant micturition reflex. Initially, when the urinary bladder is full, the stretch receptors will be signaling the S2 and S3 cords of your spinal cord, which will be sending the stimuli to the brain. As parasympathetic fibers of pelvic nerve, sensory or motor. So this parasympathetic ganglion in bladder wall will be sensed by the urinary bladder wall. The motor fibers will be sensing the stimuli to the detrusor muscle. So once the detrusor muscle sends the stimuli, the internal urethral sphincter, which is involuntary, will be releasing the fluid that is in your urinary bladder, which enters the urethra and is eliminated through the urethral orifice. So this is how the micturition reflex happens in an infant. Next, we are going to study about the voluntary control of micturition reflex. The micturition center in the pons receive the stretch signals and it integrates the cortical input, which is a voluntary control. It sends the signal for the stimulation of the detrusor muscle, and once the detrusor muscle sends the reflex stimuli, it relaxes the internal urethral sphincter. So once your internal urethral sphincter is relaxed, to delay the urination impulses sent through the pudendal nerve to the external urethral sphincter to keep it contracted until you wish to urinate. So this is how the voluntary control of micturition reflex is done in a human. By sending and receiving the stimuli to your stretch signals and detrusor muscle, which in turn delays the urination by controlling the external urethral sphincter. Thank you so much for joining GTech. Hope you would have studied about the urine formation and you would have got a preview about the process. Thank you.